Right, we're dealing with the nature of roots, guys. The nature of roots. When they say that the nature of roots are equal, this guy, a small triangle and a measure discriminant, as you can see. We measure among discriminant, and we say that the discriminant, which is that triangle, which is the delta, b squared minus 4ac. Mutako utomana formula ya quadratic formula inside the quadratic formula gara square root. That guy measure discriminant show more. So when they say the nature of roots are equal, you must make the discriminant to be equal to 0. Or monomers. The formula is this guy. Sharp. When they say that the discriminant, find the nature of roots in which the roots are unequal, it means that the discriminant must be bigger than 0, meaning ever positive for a monomers. Then the roots are going to be unequal, either it over rational or irrational. Okay. Then rabua hapa. When the discriminant is less than 0, meaning negative, it means the roots are non-real. For example, the non-real roots can allow you to have a square root of a negative number, like square root of negative 4. Is it possible? Use a calculator. If you say square root of negative 4, the calculator is going to say math error. It's not a math calculator or math error. You see it says math error. It meaning and we cannot define those values. You get what I'm saying? So they are impossible to can determine. Okay? So we call them the what? The roots are non-real. It's when the discriminant is less than 0, meaning negative. Any number that is negative, you put it inside the square root, it's a non-real root. Fine. The perfect and imperfect squares. Guys, your perfect squares is when you are having rational numbers, by the way. So you put a number inside the square root, you get a natural number. That is what you call perfect squares. Like square root of 1 is 1, square root of 4 is square root of 4 is 2, square root of 9 is 3, square root of 36 is 6, square root of 16 is 4, square root of 25 is 5, square root of 49 is 7. All those numbers that you put inside the square root and then they give you the natural numbers, we call them the perfect squares. Now when you come into the imperfect squares, which are irrational numbers, irrational numbers they are non-terminating and non-recurring. They don't repeat themselves. They don't even stop. They just keep on continuing. Maraba, but stop. The original they stop and they can repeat themselves. Check 1 over 3 over 1,3333, meaning the original number. Right what? So back in imperfect squares. Any number that you put inside the square root, it still gives you a set. We call it imperfect squares. Adequate.